Hello everyone, thank you for visiting our video. We are Team Void and we're students from SDSU majoring in mechanical engineering. Our project was to design a quick release for a vacuum viewport for ASML. I'm Hadir Sekep, I'm the team lead.
My name is Alexis Oyawale. I'm the manufacturing lead.
Shane Landis, quality lead.
Sarai Robles, design lead.
Our initial goal was to design a quick release locking mechanism for ASML's EUV lithography vacuum testing chamber. As you can see to the right, this is the ASML porcupine test chamber, and all the way to the right you can see the part that we're focused on. As you can see, it requires about 8 bolts to lock, and it takes about 15 minutes to mount or release. The main requirements for the project is that the design must hold a vacuum of 10 to the negative 3 to 10 to the negative 6 torr, and it should release within 15 minutes, should also be one-handed and easy to use, and hold a metrology of at least 2 kilograms in weight and 10 centimeter long with a 90-degree angle.
From the beginning of this project, we started with each team member suggesting an idea which could possibly be the solution for our sponsors' requirements. From this, we created a decision matrix with criteria that was important and met all of the requirements. We selected the insert twist design, which featured 2 parts, a bottom part with a spiraling inner groove and a top part with wings which once pressed into the bottom part would twist and lock into place. On the left-hand side, you can see this version 1 of our insert twist idea assembled. And once we began prototyping, we actually ran into the problem that we realized this would be very difficult to manufacture. This was because of the spiraling inner groove and the angles that we have at our machine shop. We would not be able to create this accurately. So after brainstorming, our team came up with our version 2 of our design, which featured 2 plates, a bottom and top plate, which would have ASMU 4.0 threads that would seal once twisted. We also included a top plate that was exclusive for metrology, and this would be permanently mounted onto the metrology and would also interface with the bottom plate.
For our design work progress, we had this chart that lists out our design ideations, preliminary design selection, 3D models, prototypes, final product, and testing. Even with the complications and delays of COVID-19, we were able to complete 100% of the work. This was due to us being ahead of schedule in the previous semester, and with a good division of labor led us to staying on schedule and an Excel sheet to keep everyone accountable. In our final design, we made a device that has 2 interlocking plates, V001 and V002. We also made a metrology interface that would be attached to metrology permanently. This design seals into a vacuum with the 2 Viton O-rings. We're using ASME 4-4.0 thread designs to lock the device. The benefits of our design is that it locks within 10 seconds. It can easily hold a high vacuum seal of 10 to the negative 5 torr. It's easy to use. It saved over $4,000 of a $6,000 budget. And the large radius of our plate provides more than double the torque of their old design. As you can see on the right, our device is mounted to the chamber and is holding a vacuum of 6.89 times 10 to the negative 4 torr.
And these are the 4 major tests that we conducted this semester. The first test, we failed due to misalignment because of some manufacturing issues, but we did notice that our dimensions were correct with their plate. Test 2, we fixed those manufacturing practices and kind of got the right machining tools in place, but we failed due to our O-ring groove just being a little bit too large. Test 3, we fixed the O-ring groove and we passed both the alignment and the vacuum test, getting it 2 times 10 to the negative 4 torr seal. And the final test, which passed the alignment and the assembly test, where it took less than 10 seconds to lock the top plug in place. The design was continually pumped down to reach 10 to the negative 5 torr, and was speculated to go even lower to 10 to the negative 6 torr. Here's a quick demonstration of our design being locked together. As you can see, it takes about 4 full turns and about 10 seconds to lock. If you're interested, join our Zoom meeting for Design Day, which will be linked in the description below.